Okay, so we've seen how we can look at time series and detect seasonality and using autocorrelation, and then we can even decomposition. If we're not dealing with time series, we can't really consider seasonality, unless there's something regular that happens in the data. But it's still worth looking at distribution and outliers and maybe putting in some bespoke ideas. So if you remember last week, we looked at the summary data. So this is data about the products in general, so prices and so on, as opposed to the daily sales. And we created this data frame which contains just summary data. So if you remember, there's just 25 rows, but there's 5 or 6 columns which are the price and the marketing cost and the total sales. Okay, one thing we can do is look at outliers. Okay, so here, first of all, what I want to do is label and annotate each circle. So if I know this, I can see there's some outliers in this data. I want to know which ones they are. And the easiest way to identify them is just to put a label on them. So in this figure, this is the same chart as we saw last week, a scatter plot of marketing spend versus sales, but now I've put some annotations on. And this code basically loops over the columns and annotates by putting the name of that column next to the value. The important thing to note there, sorry, let me go back. The important thing to note is that 300 is just an arbitrary variable that I've decided on because that looks about right. So it's just to push the labels off to the side. Let me show you that. Show you that by running the code. So there it is. You can see the F there is off to one side of the A. Again, if I zoom in, I think I get a slightly, it gets pushed away quite a lot. So zooming isn't perhaps such a good idea. Let's go back to the home. So you can see there, that kind of gets it fairly clearly labeled. But that value of 300 is entirely arbitrary, and it depends on what the data is. And if I wanted, if I put the wrong number in there, it might push the label too far away. It's just pushing it off to the side. Okay, so the 300 then tells us, and now I can identify what the outliers are, and most importantly, these ones down the bottom, these ones down here, K, Q, D, and U, look a bit unusual. A, F, and L, I know about because I know that they are ones where the number of sales are very high, and so the marketing doesn't seem to have any impact on them. So the AF and L, they're pushed up to the top because this is the sales on the left-hand side. But these ones down here, they seem to have very low sales, but quite high marketing. So there's something perhaps not quite right there. So there's my conclusion from that data. I've got A, F, and L are the high volume products, and the marketing isn't correlated with the sales. So, there's no marketing spend on L, for example. As you can see, it's right down here. No marketing spend, but it's still selling well. A and F have got quite a lot of marketing, but they're selling much higher than products with higher marketing. So all these products down here, where I'm hovering my cursor, all these products down here, zoom in on them. These products have much higher marketing than, say, F, but they're not selling nearly as much. Okay, and these ones down the bottom, here, K, Q, D, and U have quite high marketing but very low sales. So one way to identify outliers is to put some lines representing expected values, and this is what this code is doing here. So I'm trying to put lines on this graph. Let me show you the final picture actually before I explain it. So that's what the chart is going to look like. These lines showing expected values. So let me go back then and explain. So if I put a line with X values 0 to 40,000, Y values 0 to 40,000, that exactly represents a marketing spend of £1 per sale. So £40,000 for 40,000 sales, or £20,000 for 20,000 sales. So that's this line here. That's the red line. Let me highlight the code. It's this line here. You can see the values go from 0 to 40,000, 0 to 40,000. The line style is a dotted line and it's red, and that label, we've labeled it was £1 per unit. Whereas if I imagine a line of X values going from 0 to 40,000 with corresponding Y values going from 0 to 80,000, so here that would be like 50 pence per sale. So for 40,000 spend, I get 80,000 sales. So that's 50 pence per sale. And so I've represented that here with this line here, this orange line, which I'm highlighting, and so on. Okay, so you can see the X values are staying the same each time, 0 to 40,000, but the Y values are going from 0 to 20,000, 40,000, 80,000, 160,000. So that's then determining what that represents. So when I draw that chart, let's run that for real. The lines are then able to identify for me where certain values lie. Oops, I don't think I want it full size. Quite like it square. So there you go. Anything above the green line is below 25 pence per unit sold. Okay, so above the green line is below 25 pence per unit. So it's very low marketing for these AF and L at the top here. Anything between the orange line, or I think, is it orange or red? Yeah, orange and red. Anything between the orange and red lines, which is where most of them are between £1 and 50p per unit. So that's the kind of normal. And these ones then, therefore, down the bottom, these below this black line are more than £2 per unit. Okay, so we're spending more than £2 of marketing for each item that we're selling. So we don't know because we haven't looked at the data, but is that a good idea for our data? Might be something to handle with the business analysts, but we may be able to get a bit more information out of our data sets next week. So I'll leave that with you, but we'll look at that in a bit more detail next week. Okay, there's my conclusion. AF and L have very low marketing, but DK, Q and U have more than £2 per sale spent. Might be excessive. So those ones down the bottom there. Okay, so let's finish off the lecture. So the data conclusions are, first of all, we must always remember we're not making business recommendations, but we can easily visualize the distributions in the time series and spot outliers. We can see some seasonal variations, particularly quarterly and weekly, but not for everything, just for certain products. There's very marked weekly seasonal variation and some marked quarterly variation for some products. And when we go back to data that isn't time series, we can identify outliers, perhaps with very high and very low marketing spend per sale. Not saying that that's too much or too little, it's just saying that that's out of the ordinary, because the ordinary there is sort of between the orange and the red lines. The very high sellers are very low marketing, and there's certain very low sellers that are very high marketing. Okay, in terms of what we've seen, we've looked at this idea of distribution. How is our data distributed, and what's driving that? So we can see we can measure the distribution with histograms and box plots. Those are a good basic tool to look at distribution and get some sense of what's going on. If we think there's seasonality, we can use autocorrelation and even seasonal decomposition to attack that. And we can also use other tools, more bespoke tools to identify outliers and try and spot what is going on there. I should say these are not the only ways of visualizing distribution. So you may come across things like density plots, which are like a smoothed version. If you imagine a histogram and sort of smoothing it over, then that's a density plot. And a violin plot, which is a kind of combination of a density plot and a box plot. Those are quite nice. I thought about introducing them. I didn't in the end. But if you're interested in more of this, doing a bit more, then I would look at violin plots because they kind of combine both density and box plots. And you'll see that gives us a toolbox of techniques that are able to explore the distribution in a bit more detail, but some techniques will suit certain data sets better than others. Okay, I hope you found that interesting. I'm going to finish here.